All right, so we are starting a new chapter, and this chapter is, I'm gonna share my screen, I guess. Right. All right, so no question, right? All right, sounds good. So in the previous chapter, we kind of like started organic chemistry, right? And then we learned about a class of compounds, which were the first one was the hydrocarbons, and whenever we were learning the hydrocarbons were the compounds where we have only carbon and hydrogen, right? And there was no oxygen, there was no nitrogen. So in this chapter, right, we are going to go a little further, and now we are going to actually adding oxygen and nitrogen as well, right? So these are CH is a hydrocarbon, but obviously, as we said, you can actually switch the elements, right? You can actually put oxygen, nitrogen. You can even like put, halogens, fluorine, chlorine. We're not going to go that further, but we're going to see this type of compounds with oxygen and nitrogen in today's lecture. Okay, so functional group is, again, when you look at the functional group, you're going to actually tell and classify what kind of group is this, because if you look at the functional group, that's gonna be the one that's gonna determine the physical properties and the chemical properties. Like, meaning, if you have, for instance, OH, right? Let's say, and if you see an OH in carbon to attach, right? And so you're gonna see a similar properties basically with OH. Okay, so that's why you need to really, if I give you a molecule, right, then you should be able to tell me what kind of functional group is that. And usually, as we said here, we represent this functional group by, like whenever we have carbon attached to a functional group, we actually symbolize this carbon, right, alkyl chain as R as well. So R means alkyl chain, right? The alkyl chain, what was the alkyl chain? Remember, if you have one less hydrogen than the regular one, that's an alkyl chain, right? So instead of a regular hydrocarbon, right, let's say this guy, so I supposed to have like 3 hydrogen here, right? So if I replace one of them with OH, then this is my alkyl chain, right? So I represent this as R, basically. Okay, that's what it is. And so I'm going to actually start. First one that I want to start is, maybe I can actually switch to my, or maybe I can continue here. So the first one that I want to talk to you is alcohols. Okay, so as you can see, if I have a hydrogen here, right? If this will be a hydrogen, this will be actually ethane, right? But as you can see, instead of an hydrogen, I can actually put OHs, okay? And so again, OH, whenever we see in organic chemistry, like whenever you have a sodium hydroxide, right? OH is called hydroxyl functional groups, okay? And so whenever you have a hydroxy group attached to a carbon directly, then we are going to call you an alcohol, okay? So you're going to be alcohol, right? And as an example, right, you can write this as a condensed form as CH3, CH2OH, or like that, or you can actually write it like that, right? This is also ethanol, right? This is a line structure that we learn, 1, 2, 2 carbon. Okay, and as you can see, there's going to be a slight differences between ethane and ethanol, right? Because now you have 2 different elements here, right? One of them is carbon and one of them is oxygen, right? If you don't have the oxygen, it will be just carbon and carbon, right? and they will be actually sharing this bond equally, right? Because now there's two electrons here, right? And they will be sharing this electrons equally. But now, as you can see, one of them is oxygen. And if you can remember the electronegativity that we talk about it, right? This is the order, right? Carbon, nitrogen, oxygen, and fluorine. Fluorine is being the most electronegative element. However you get close to fluorine, you're going to be more electronegative. So oxygen is more electronegative than carbon. So this will actually pull these bonds more stronger than the carbon does. And this will actually create a partial negative charge on oxygen and partial positive charge on carbon. That's why you're going to see this actually polarized, right? This is polarized bond, polarized. Meaning that if you are polarized, right, then it means you are polar, okay? And so therefore, it will have a different properties than the hydrocarbons, such as it will be, right, if you look at the hydrocarbons, right, if you have just an ethane, right, this molecule, CH3 and just CH3, this is non-polar because you're not polarizing the bond. But if you look at the ethanol, which is the alcohol, then it is polar. Make sense? So that's why you're going to be actually, dissolving, right? All the alcohols you can dissolve in water, such as like all the polar. So like if you are polar, we learn in the solution chemistry, right? If you are polar, you're going to be actually dissolved in the polar solvents. So therefore, all the alcohols is going to be dissolved in water. But if I can give you some examples, the structure of the alcohol is going to be important, right? Why? Because again, you have this alcohol here, right? Not sure if I have. Let me go back to my. Okay, now it's clean. Okay, so we are talking about alcohol. Let's write it down here. Alcohol, and alcohols are again whenever you have R attached to OH, okay? And so if you compare these two alcohol, right? Let's say this is just an ethanol, okay? Okay, this is 1 and 2 carbon, right? So this is ethanol. So if you increase the carbon chain, right? Now if I'm going to increase the carbon chain, and now I'm going to make 1, 2, 3, 4, 5, let's say 6, and then if you increase even like 7 or 8, right? So as you can see, if you increase the carbon chain, right? So what you are doing is, again, you are actually increasing the non-polar side, right? We said that, right? If you have just a carbon and carbon, it's going to be non-polar, right? So therefore, if you increase the carbon chain, and if it's usually if it's larger than, let's say C6, okay? So if it's larger than carbon 6, then as you can see, right, you are increasing, right? You're increasing the non-polar side, right? So now this molecule is becoming not, even though it has an OH, group, right? It will not be able to dissolve easily, basically. Okay, so that's why, right? And the reason is because again, it has this kind of like a tangle, right? Like a tail, right? It gets longer and longer. Then now those tails is going to interact with each other, right? They're going to stack them together, right? More nicely, okay? And so therefore, you won't be able to actually dissolve this anymore, all right? Make sense? So basically, if you increase the carbon chain more than 6 carbon, right, then those carbons are going to interact with each other more stronger, right? And so therefore, you won't be able to dissolve this alcohol anymore. Okay, that's what it is basically. That's what I was telling in the other slide. Okay, any question with this so far, everyone? All right. So what about the naming? So the naming is, again, we learn naming in the hydrocarbons, and I told you that you're going to be actually applying the same naming, right? There's not going to be too much differences. So if I want to name this, right? If I didn't have any hydroxy group here, what will be the name of this compound? Only 2 carbon. 1, 2. What's the name of this hydrocarbon? Anyone?
Ethane.
Ethane, right? Ethane. So now, right? So you have actually 2 chances, okay, when it comes to giving the IUPAC name. So since you have alcohol, right? What is this functional group here is? Again, you have alcohol, right? So my functional group here is all, okay? Right? Maybe I can write better. So I have all. This whiteboard is acting weird today, but I don't know why. Alcohol, right? Alcohol. So now this is ethane, but again, I am adding actually a OH here, right? So this is not a ethane anymore, right? This is a hydrocarbon. Now this is an alcohol. So I need to indicate that. So it's going to be, I'm going to drop the E at the end, and I'm going to add all, ethanol. Oops, let's use a red one. Okay, ethanol. This is number 1. You can use this naming, or you can actually, the second one is a little bit harder, but you can still do that. The second one, these 2 are again used in the IUPAC system. You can name the alkyl chain, right? So if you look at this one, what alkyl chain is this? You have 2 carbon with 1 less hydrogen, right? It was ethane, but if it's an alkyl chain, what do you call that? Remember?
Ethyl.
Ethyl, very good, right? So it's going to be ethyl. So alkyl chain is going to be again ethyl, and now you're just going to call the alcohol. So it's going to be ethyl alcohol. Make sense? So these 2 are going to be the IUPAC name, and then both of them are used, commonly. It's the same it's a little different techniques, but you can use both of them basically.
So you could use both of them to say ethanol.
Exactly. If you say ethanol and ethyl alcohol,
Yeah.
both of them are fine. All right. Very good. All right. So let's look at this one. I have some notes from the other sections, I guess, or from the fall. And by the way, ethanol is, you know what ethanol is, right?
Yes, the additive for gasoline these days.
Yeah, but also
Regular drinking alcohol.
Huh?
Drinking alcohol.
Exactly, drinking alcohol, right?
Moonshine.
One of my professor was saying, he's like his friend. But not all alcohol are drinkable, obviously, because just ethanol is drinkable. Like if you drink methanol, right, which is this guy, and in some countries, they do that, because it's cheaper. They mix this with ethanol, and then it's gonna cause a lot of problem actually. You don't want to be drinking like methanol, and I believe it can cause you blindness too if you drink too much. So what will be the name of this guy here? Again, the naming is same rule, right? You're gonna treat it without like seeing the OH, right? So how many carbon? You're gonna find the longest chain. Find the longest chain. So it's gonna be 1, 2, 3, 4. What is the simplest hydrocarbon with 4? How would you name it if it will be just hydrogen here?
Butanol.
Butanol, right? Very good.
Yeah.
So it's going to be, again, the first one, if you look at one, this is going to be butanol. right? It was butane, and I'm just going to add butanol. But now, as you can see, this is butanol too, right? 1, 2, 3, 4. So this is butanol too.
Yes.
So which one are you talking about? What should I do here?
The second one should have a 2 to it, 2/butanol.
Very good, right? Why it's 2? Why it's
Because-
not 3?
Because you go the other way. You
Okay,
least
right?
number. Yes.
Very good, very good. So now 1, 2, right? Because we want to give the smallest possible number. So it's going to be 2-butanol. And this one is, again, it looks like 4, but it's not, because you just flip the molecule. It looks like 4, but it is tricking us, right? It is actually, indeed, it is 1-butanol. 1, 2, 3, 4. We want to give the smallest number. So this is 1-butanol, and the other one is 2-butanol. Okay? Make sense? Or you can just say 2-butyl alcohol. It's the same thing, basically. But 2-butanol is, I guess, that's easy, right? Less wordy. Right, makes sense, right? Okay, and then also in this chapter, we were actually also categorize the alcohols, okay? And you might be asking why we are doing this, because we are not really, doing any reactions, but when we do the reactions in organic chemistry, this becomes actually important, okay? And so when you look at the alcohols, there are actually 3 different types of alcohols and categories. And the first one is the primary alcohols. And what is primary alcohol means is you're going to look at the OHs, okay? This is the OH, right? And I'm looking at the carbon that's attached to, which is this carbon right here, okay? And I'm going to count how many carbon or alkyl chain or carbon branch attached to this carbon, okay? So if you look at it, right, as I can see here, let's pick up another color, right? I see there is 2 carbon attached to it, right? You see that, right? So again, we are not gonna count this 2, but it's only 1 branch, right? This is only 1 branch. You see, this is like a 1 branch here. You see that, right? So
Yeah.
therefore, I'm gonna say that this is primary because there is only 1 branch attached to it, just like my arm. Imagine my arm, right? Even though we have two carbon, it doesn't really matter. If you have hundreds of carbons, right, it's gonna be still only 1 branch, right? So if there's only 1 branching out from that carbon, that's a primary carbon. Make sense? Okay. And so if you have, again, now look at this carbon. Now, again, I'm looking at the same carbon that's attached to OH, right? So, but as you can see, this carbon has 2, even though it's the same, right? Metal doesn't matter, but you have 2 branch. One is branching out this way, the other one is branching out this way. So therefore, it's going to be a secondary carbon. And finally, now look at this carbon, right? I have actually, again, OH attached to this carbon here. And it's actually, as you can see, branching out in 3 different ways. So 1, 2, and 3, okay? Again, it doesn't matter how many carbon do you have. Sometimes students are saying, oh, you have 2 carbon here, so it's primary, or no. You're not gonna count the carbons. You're just gonna look at the way how this carbon is branching out, okay? So again, you're gonna see primary, secondary, and tertiary. You're gonna see this thing in the amines as well when we actually when we're gonna do the amines in the last part of this chapter. It's the same thing basically. Okay. All right. So if I want to ask you, then how would you name this alcohol?
One, two, three, four, five, six. Hexanol.
Okay, what's the name?
Well, you have 6 carbons all bonded together, so that's cyclohexanol.
Okay, very good, right?
Yeah.
Again, it's gonna be 6 carbon, but since it's actually cyclic, it's gonna be cyclohexane, right? But now it's an alcohol, so it's gonna be cyclohexanol, right? Very good. Okay. And so if you look at this carbon, right here. So so far, like if I want to classify this carbon, do you think it's going to be primary, secondary, or tertiary carbon?
It's going to be tertiary.
Tertiary?
Yes.
Why?
Because
It's attached to, again, I'm looking at this carbon.
Everything's attached. All the carbons are attached.
Attached, but how many branching does this carbon has?
Well, normally without the alcohol, yeah.
Huh?
Normally it would be 6, but now that you have the alcohol, it should be 1.
If this is tertiary, what about this one?
Ah. Okay.
Again, I'm just looking at this carbon right here, the red carbon, and I'm just going to look at I'm not counting this one, Carlos. This is OH, right? This is attached. So I'm looking at this carbon, and how many branching does this carbon has? So there's one branch this way, right? Branching out, this one.
Yeah.
And there is another one here.
All right, so there's 2, yeah.
Okay, so it's 2.
Yeah.
Sometimes students count this, since it's cyclic, they count it as 1, but it's not 1, it's 2, okay?
Okay.
So as you can see here, there's a differences now. I have actually branching out like in 3 different ways. This is 1, this is 2, another branching, and this is another one branching, right? So this is 3. So therefore, this is going to be my tertiary alcohols. This is going to be my secondary alcohols. You see that, right?
Yeah, I see that now. So you just count the branches.
Exactly. Okay. Makes sense, right, everyone? Any question with this? Okay, I'm gonna pass this again. We don't have to worry about this. And so now I'm gonna look at another functional group that I want to show you. And this one is called actually ethers. Okay, so in ethers, now instead of actually, this hydrogen right here, right? You see this hydrogen? Again, this is actually bonded to oxygen, right? Like that. In reality, okay? So I can actually, again, replace this hydrogen with another alkyl group, okay? So the ethers is, right, whenever you have oxygen attached to another R group and attached to another R group, like that, okay? These are gonna be ethers. This is actually, as you can see, if you have a water molecule, this is how the water molecule looks like, right? You have oxygen right here, right? Oxygen and oxygen. As you can see, let's make this water molecule happy, right? So if I replace this hydrogen with one of the R, then you get alcohols. You see that, right? And if I replace this hydrogen also with another R group, then you got ethers. Okay, maybe you can like remember from that. All right. So you have 2 R group basically attached to oxygen. All right. So that's going to be my ether functional group. And so the naming is very simple. Okay, and so how you're going to name this? You're just going to name, right? Let's take a look at example of one of them. Let's say CH3O, CH3. Okay, so you're just going to name the R group. And what is this R group here? CH3. What do you call the CH3? Anyone?
That should be
If you have one carbon, what was that? Methane. But
Methane.
now this is an R group. What do you call it?
Methanol.
Nope, it's methyl, right? Again, the R
Oh,
group
yeah,
is
yeah.
methyl. So you have methyl, and since you have two of them, I'm going to call di, right? And I'm just going to add the functional group, which is ether, dimethyl ether. Make sense?
Okay, all right, okay.
Okay. And so if you have, again, another maybe, let's say C2H5, C2H5. Again, what's the R group here? This R group, what's the name? If you have two,
Ethyl.
ethyl, right? If you have two carbon, it's ethane. Now it's an R group, so it's going to be ethyl. So it's going to be ethyl. And since you have actually two of them, right? Now I'm going to call di-ethyl. And then I'm going to add the functional group name ether. Very simple. Okay, again, you can have same R group, right? Which is, again, here in this case, we have two of them are ethyl. And if you have different R group, then you're gonna do the same thing, right? If you look at this example, for instance, maybe I can just put it there. Right, so let's say you have on the one side, you have methyl, on the other side, you have ethyl. How would you name this?
Ethyl ether.
Yep. Again, this is the one side is this is methyl, right? You're just going to name the alkyl chain, and this is ethyl. And when it comes to putting the substitutions, we're going to look at the alphabetic order. So E comes M, so it's going to be ethyl, methyl, and then I'm going to add the functional group, which is ether. Make sense?
Hold on. You're going to lose me with all this alphabet.
No, it's the same thing. See, we are doing the same thing. We're just like switching a little bit. But again, we did this when we named the hydrocarbons, right? So we are just building up, right? So instead of calling ethane, we're just going to call ethanol. And now it's ethyl methyl ether. And one thing that I want to mention, I'm not sure if I have it in the slides. Let me see if you're talking about it. Okay, so diethyl ether, okay. Yeah, you don't have to worry about the acetals and hemiacetals. I don't want to like confuse you because whenever I talk about it, students are actually getting confused. So, so one thing that I want to mention here is again, alcohol. If you look at the alcohol, I don't think I'm mentioning it in the slides, but I think it's worthwhile to know, right? If you look at the alcohols, right? Even though, let's take a look at this two molecule, okay? So C2H, what's ethanol? C2H5H6O, okay? Both of them have same formula, molecular formula, but one of them is, again, ethanol. This is the beauty of organic chemistry. You see that, right? The molecular formula doesn't mean anything for us. We need to look at the structural formula in order to understand what this molecule is and why the molecule is acting. Look at these two molecules, right? So these are, again, we are going to call them isomers too, right? I mean, yeah, they're isomers. They are like constitutional isomers. Well, I wouldn't be calling it isomer, but yeah, technically isomers. Okay, so if you look at these, yeah.
Sorry, question. The ethers always only two R groups?
Yes, always.
Only two. Okay.
Yep. Because if you have more than two or less than two, then you're going to have a different functional groups. It's going to call, if you have one, then it may have actually, again, depending on the structure, but you can have like acetals or hemiacetals. But we're not going to get into that. So if you look at these two, right, this is ethanol and this is ether, right? This is methyl ether. And if I want to give you the boiling point of ethanol, do you know boiling point of ethanol? You know what temperature that does the ethanol boils? Anyone? All right, I'll give it away. It's 80 actually. It's less than water. It's 80 Celsius. And if you look at the boiling point of ether, does anybody know? Again, I don't know exact boiling point, but it's around room temperature, meaning that it's around like 20 Celsius. Okay, you see the difference right here?
Yeah.
There's a huge difference, 80 to 20. Back in the days, ether actually, you know, I still see that actually in some of the movies, old movies, you know, because it has a very low boiling point, right? It can evaporate so easily. So if I have a glass of beaker, I mean a glass of ether, if I put it here, it will evaporate, right? Without like, again, because the boiling point is, it's gonna boil. It's just, you know, you're not gonna see it's gonna boil, but it's gonna evaporate.
Take a coffee.
Coffee?
And so back in the
Okay.
days, people actually
Yeah, I
used
know.
ethers
Oh.
to put people in sleep, right? And like whenever they were gonna, they were gonna make, you know, like surgery and things like that, they used to put like ether so that you can, you know, faint or whatever. So the reason is again because of this hydrogen bonding. So you see that, right? This hydrogen bonding make a huge
Kobe, go inside.
differences.
Oh.
Okay, Jessica, we can hear you if your sound is coming too. Yeah, it's okay. I mean, I don't mind. But
Sorry.
yeah, it's okay. It's okay. And so if you look at this, right? So it can actually make a hydrogen bonding, but here this oxygen doesn't have a hydrogen. Okay, so essentially this molecule, right, this oxygen has two lone pairs like that, because every atom needs 8 electrons. Again, you don't have to know this, but it's a kind of like a side note, but it's a nice note. So if I bring another ethanol molecule here, you see that, right? You can make actually hydrogen bonding between this hydrogen and this oxygen. You see that, right? This is not a real bonding, but it is a bonding. Okay, it's not as strong as sigma bonding, but it is strong. And as you can see, if you have millions of this ethanol molecule, you're going to have the same thing with every single one of them. They're like tying together. Okay, and they don't want to like separate because there's a strong interaction between them. You see that, right? And so in order to you know, boil, you have to break this bonding. Okay, and there is not only one of them, there is a million of them. Okay, but if you look at this molecule, this oxygen, right, doesn't have that. You can only have hydrogen bonding if you have oxygen attached to a hydrogen, or fluorine attached to a hydrogen, or nitrogen attached to hydrogen. Okay, and so as you can see, this ether molecule lacking that, and they cannot really come together as a molecule, right? They cannot really get closer. And so therefore, you see the boiling point is there's 60-degree differences, and it's all due to the hydrogen bonding. Okay, so it's good to know. All right, so now I'm gonna move to another functional groups, okay? And in these functional groups, we're gonna still have oxygen, but we're gonna see a new bonding, okay? And this bonding, you know, this bonding is, by the way, you see what kind of bonding is this? Carbon to oxygen. What do we call this bonding? What was it? Single bond, right? Single bond. Okay, so now we're going to actually see, we're going to start seeing a new type of functional group. And now we used to, again, see only one carbon. I mean, sorry, one bond. Now we are going to see actually a double bond. Okay, we're going to see a carbon, right, attached to an oxygen with a double bond. Obviously, this is going to be so much different than this bond, right? Because again, this is pi electrons, right? So the functional group is going to totally change. So the first one that I want to show you here is, again, you have carbon attached to an oxygen, okay? And then you can have, again, carbon needs to have 4 bonds, right? So you can have, you cannot just leave carbon with just 2 oxygen double bond, right? You need 4 bond. So the possibility is then you can have 2 possibilities, and these are the first 2 ones that I want to show you. Maybe actually I can have more space here. Okay, so ethers, let's write it down, ethers, like that, so that here we have a nice table. Okay, so the first one is that I want to show you here is, again, we are talking about carbonyl. Okay, so the first one is actually aldehyde. And then the second one, maybe I don't need to separate them because they're kind of like related. Let's say the second one is ketone. So what are they? So aldehyde is, right? So you have carbon attached to an oxygen with a double bond, okay? And carbon needs to have 4 bonds, right? So this is the first one. And again, same thing here, ketone with 4 bonds, okay. So now, right, in the aldehyde, you can either have an R and R group right here, right? If you have both of them, right, R and R and R and R. So what's the difference between aldehyde and ketone? R means, like, again, this carbon is attached to another carbon, right? Attached to another carbon, alkyl chain basically. So if I have both of them R and R, then it will be the same, right? There won't be the differences. But in the aldehyde, here's the difference. One is actually just a hydrogen. That's very important, okay? It's just one hydrogen, okay? And so whenever you have this situation, then the functional group is gonna be aldehyde, basically, okay? But whenever you have 2R group, then it's gonna be ketone, right? Makes sense? And so if you look at these aldehyde and ketones, by the way, it has all these actually nice flavors. If you see in the flavor and fragrance industry, they use all this aldehyde and ketones, right? Like many flavors that you see in, like cinnamon, for instance, right? Cinnamon, it's coming from cinnamon aldehyde, you know, like benzaldehyde, for instance. It's the taste and the flavor of the almond, for instance, right? So those are all you know, the thing that we've seen in our regular life, but we don't really appreciate it, but they are actually aldehyde and ketones, okay? So these are my aldehyde and ketones. And so let's start from the aldehyde first. Oh, by the way, I forgot to mention, but we call this actually a carbonyl, right? This is another technical term that we use. Again, if you have any carbon attached to oxygen like a double bond, right? Again, this is not a functional group, but we call this is a specific bond, right? Carbon with 2 double bond. So we call this, again, this is called carbonyl. Okay, carbonyl. Carbonyl, if the carbonyl is attached to an hydrogen, then it's an aldehyde. If the carbonyl is attached to 2R group, then it's a ketone. And how will I name this? Again, it's the same thing. It's the same thing that we are doing all over again, right? So let's look at this aldehyde. Okay. So how many carbon do you see here? 1, 2, 3, right?
Yeah.
And what is the name of 3 hydrocarbon? Propane, right?
Propane. Yeah.
Okay, very good. And so all you have to do is here is you're gonna drop the E. Yeah, we're just playing the letters. That's what we are doing.
Propanol.
Okay.
Propanol.
Not known, but it's an aldehyde, right? So I'm gonna use this al here, okay?
Okay.
Al. So it's gonna be propanol, okay? You see that, right? If you put O instead of A, it will be propanol. So make sure you have the right letters, okay? So letters are becoming important, as you can see.
Sir, quick question. With the aldehydes, the aldehydes are always double bonded carbon,
Carbonyl. Yep, you must have this carbonyl group in all.
and that has to be a double bonded carbon then.
Yep.
All right. So if it's a single carbon, it's not an aldehyde. It's more of a ether or alcohol.
Well, this is not carbonyl. Again, this is not carbonyl, Carlos. These are not
Okay.
carbonyl.
Okay.
These are not carbonyl. These are just carbon attached to an oxygen. We don't call this carbonyl. There must be a
Okay.
two double bond.
All right. All right. All right. Double bond.
Okay. All right. And same thing goes. So should I call this, do you think 1-propanol or should I just leave it propanol? Or let's do the ketone, and then I think you will see what I mean, okay? So let's do the same thing with the ketone. And let's actually name a little longer this time. 1, 2, 3. So now you see it, right? How many carbon do we have? 1, 1, 2, 3, 4. Okay, so for ketone, yeah, let me explain because we didn't cover this yet. So the same thing, right? If you have butane, right? If you have 4 of them, we are going to call butane, right? The name is butane. But now we are not butane because we have this functional group, right? So I have to change it. So for ketone, I'm actually taking the last 3 letters. Again, you might be asking why we are doing this aldehyde here and why we are doing ketone. Again, these are the rules, right? You cannot discuss the rules, okay? So now I'm going to use on, and I'm going to add that to here, okay? So it's going to be butanone, okay? But as you can see here, right? For the butane, I mean, for the ketone, you might have isomer problem, especially if you have a longer chain, if you have 5, 6, right? So you should tell me where this carbonyl, right, is. That makes sense? So is it like 1 butanone, 2 butanone, or 3 butanone? So therefore, if you have a ketone, you're gonna tell me where that carbonyl is. And again, same rule applies. We wanna give it the smallest possible number always, right? So therefore, you're gonna start from the other way around. So it's gonna be 1 and 2. So this is gonna be 2 butanone, okay? But for the aldehyde, you don't really tell me 1 propanol, right? Because you're not gonna have 2 propanol, no way, right? Because in the second carbon, you're gonna need this hydrogen always, right? So if you need a hydrogen, then the aldehyde has to be always at the end, basically, right? Because you cannot have in the middle, like you cannot have a hydrogen here. Right. Can you? No, right? Because we are violating the octet rule. We have more than 4 bonds here, right? So therefore, you don't need to do that in the aldehyde because it's redundant, okay? Only for the ketone, only. Make sense? All right, any question, everyone? Again, this is propanol, right? So let's do this. I already give you the example, but here, see. So now, how many carbon do I have? Let's blow this up a little bit so that you can see better. So you're gonna count the number, same thing. See, we are doing same thing. We've been doing it. You're just gonna count the carbons and then you're gonna name it accordingly. So if I count, it's gonna be 1, 2, 3, 4, 5, and 6, right? So what's the name of 6 carbon? Hexane. Okay, but now as you can see, I have an aldehyde functional group, so I need to change this accordingly. So I have to come here and pick a color here. Let's pick up white. So I need to drop this E and make it an aldehyde, right? So it's going to be again hexanol. Make sense? And again, I don't really need to do like 1 hexanol because it's one hexanol. right? You cannot have 2 hexanol or 3 hexanol. Okay, hexanol is going to be always 1 hexanol. Make sense? Okay, any questions, everyone? I hear none, and okay, I'm moving on. So this is again ketone. Okay, let's do, we already give the example. Okay, what about this one? Actually here, I kind of like made a mistake. I just realized, because you don't have to tell me this is 2-butanone either, right? Because in every case, right, you're not going to have any 3-butanone, right? So again, this is a very good example of the redundancy that I was referring, right? So this 2 is very redundant here. I was just explaining to you why we need to give the carbonyl, but in this case it's redundant. Why? Because again, you cannot have 3-butanone, right? Because whatever you are saying 3-butanone is, indeed it's 2-butanone. Make sense? And you cannot have 1-butanone either. So therefore 2 is redundant here. So that's why you drop it. But as you can see in this case, where is it? Yeah, here it's not redundant, because the carbon chain is longer, and so now it's going to be important. So again, you're going to do the same thing. Count the number of carbons.
This 3 hexanone.
Okay, seems about right, right? So you're going to count the number of carbons. So it's going to be 1, 2, 3, 4, 5, 6. So I know that if it's a 6, right, then you're going to have hexane. But now you have carbonyl here, right here, right? This is carbon, the double bond oxygen. So it's going to be again now hexanone, right? Because now you have a ketone, and I drop the E and add on hexanone. But now, right, are you talking about like 2 hexanone, 3 hexanone, right? Or you won't have 4 hexanone, it's going to be 2, 3, right? You have 2 isomer problem. So therefore, you got to tell me which hexanone are you referring. So now you have to numbering it, right? So as you can see, if I start numbering from left to right, it's 4. But if I start from here, 1, 2, 3, this is less. So therefore, this must be 3 hexanone. Okay? Make sense, everyone? Good?
Yes.
All right, that's what I want to hear. All right, and so now again we are coming to a little further, but as you can see, we are building up. And now what I want to show you here is, right, we are going to still have our carbonyl, right? So we're going to still have our carbonyl. Let's say these are carbonyl, okay? So now you're going to change the carbonyl, right? Right, you can actually have, instead of a carbon, right, you can actually have different substitutions here and here. So if you have one R group here, and now if I want to change the other one to OH, you see that, right? And so you can do that. Again, this is the, again, beauty of organic chemistry, right? By changing one of the elements, you're getting a different functional group. And so this will be, again, now becoming a carboxylic acid functional group, carboxylic acid functional groups. And again, this is different than aldehyde and different than ketone, and it will have a different chemical and physical properties, okay? And again, we are going to call this a carboxyl group, right? If you have this group, this is a carboxyl group, and again, this is the name of the functional group, carboxylic acid. And then you might be asking why this is acid, because remember the definition of the arrhenius acid, right? What was the acids? Acids were, right, anything, if you have HCl, for instance, let's pick a white color, HCl, this is an acid because it gives up H pluses into aqueous solution, okay? So as you can see, this hydrogen is acidic hydrogen, and this compound can give up the hydrogen into the water. It's fine, it can survive without that hydrogen. So therefore, we're gonna call this acid, okay? It's not gonna be as strong as hydrochloric acids, but it will be an acid. And if I wanna give you an actual example before we move into before before the naming, right? So if you look at this acid, okay, and again, if you look at the IUPAC name, the IUPAC name is going to be different one, but then we have some common name actually, okay? So the common name is this guy is, this is actually, does anybody know? This is acetic acid. You know what acetic acid is? This is vinegar. Okay, so as you can see, vinegar is acid, right? But it's not gonna be like very super strong acid because we can eat it, right? So it's not gonna really do anything to us. Okay, why? Because again, it's same thing, right? It can give up this hydrogen, right, into aqueous solution, and so that it can create, you know, like the acetate ion, which is this guy. And so what about the naming? So the naming is again, same thing. Let's go back to our screen again. And if I want to put the acetic acid again, acetic acid, again, this is a common name. But if you look at the IUPAC name, right, you're going to do the same thing. You're going to count the carbon of number atoms. And so it's going to be 1 and 2. What is the 2 carbon name? The simplest carbon name, it's ethane, right? So now this is not ethane because now you have this carbonyl with a hydroxide, right? This is carboxylic functional groups. So therefore you need to change that. So you're going to be actually again dropping the E at the end, and you're going to be adding oic, ethanoic, and then you're going to add acid. Okay, ethanoic acid. Again, this is the IUPAC name, but the common name, there's going to be some common name, and the common name is going to be acetic acid. Nobody's going to call this ethanoic acid, by the way. Everybody's going to call this acetic acid. And there's going to be some common name for, I forgot to mention, like for instance, if you look at this guy here, this is again, I'm kind of like moving back to ketone. So how would you name this? It's going to be 1, 2, 3, right? So we have 3 carbon, correct? Prop. It will be propane. And now I have to drop the E. If you're having a trouble, you can always do this, right? Drop the E and make it on. Propanol.
Propanol.
Yep, propanol. And again, this is propanol, right? And you cannot really have 3, like you don't have to worry about whether it's 1 or 2 or 3. So it's going to be still, you know, you don't have to name the carbonyl basically because it's redundant. And so this is again, this is the IUPAC name. And if you want to look at the common name, this is actually, does anybody know what this is? You can actually buy this at the grocery. And so this is actually acetone, right? Acetone. They use that, you know, for nail polishing, or to kind of like clean your nails, right? If you have nail polish. And so because acetone is again very polar, and it can dissolve the polar substance, right? It's much polar than water. So water cannot like erase the paint, right? Or the whatever that you are using, the dye on your nails or whatever, right? The acetone can actually, right? Because it's polar, so it can actually, you can actually just scrub it, and then it will just get rid of it. Okay. So again, this is acetone, 3 carbon.
Professor, I have a
Okay.
question
Uh-huh.
about ketones, like a side question. Like,
Mhm.
you know, ketosis is like when you have too many ketones, you know, in your body. And that, like, you know, is a side effect of, like, you know, like the keto diet, for example. But do you know, like, if it's the same kind of ketones? Is it
No,
all, it's
no.
different?
Yeah, it's different because again, they call it ketones, but you're gonna see actually those are not like the aldehydes or ketone functional groups. Those are actually, those are carbohydrates, and in the carbohydrate section, we are gonna actually see that if you have you know, aldehyde or ketone in the carbohydrate, we're gonna actually name it as like aldose or ketos. Okay. And so it's a different. I mean, it's still a functional group, but it's not ketone. It's actually carbohydrate.
Okay.
Mhm. All right. So again, this is the naming, right? And let's go back to our slides again. And if I want to name this right here, how would you name this? Again, we're just going to count the carbon. 1, 2, 3, right? If you have 3 hydrocarbon, it's going to be propane. But now this is carboxylic acid because I have this carboxylic acid functional groups. So it's going to be again propanoic acid. I'm just going to drop the E and add OIC and acid. Okay, and again, there's no, you don't really tell me if it's 1 propanoic acid or 2 propanoic acid, because you cannot have this in the middle, right? Because carbon needs to, again, 4 bonds here, and it's already 4 bonds. You cannot put this in the middle here, right? So therefore, you don't have to tell me 1 propanoic acid, because again, 1 is redundant information again. Okay, and so now if I want to give you this one, I already give you the name, but same thing, right? We're just going to count on carbons. So count the carbons, 1, 2, 3, 4, 5. So the 5 carbon is pentane. And now I'm going to drop the E and add oic. And then give the acid, pentanoic acid. Make sense? Okay. Anyone? Any question? And if you look at the actually butanoic acid, I believe, again, there's a common name for butanoic acid as well, but this is actually where it's coming from. 1, 2, 1, 2, 3, 4. This is actually, again, butanoic acid, 1, 2, 3, 4. And the common name for butanoic acid is actually butyric acid. And again, the name is coming from the butter, actually. So if you have butter, you will see some butanoic acid in your butter. Okay, it's kind of like a side note, but it is a good note. And the other thing that I want to mention is students are making some mistakes that I've seen over the years, right? They count, right? Whenever they want to name this, I've seen students naming this like propanoic acid, right? They don't count this carbonyl group here, right? They treat it as a functional group, and they say we have 1, 2, and 3 carbon. So this is propanoic acid, but that's wrong, right? Because you have to count this carbonyl right here. This is part of the chain as well, okay? So therefore, there is actually not 3 carbon, but there is 4 carbon here. So it's 1, 2, 3, and 4. Make sense?
Yes. So you always count the carbon that is double bonded to the oxygen.
Yes, you're going to include that as well. Yep, that's part of the whole name, whole last name. Otherwise, you're going to give the wrong last name. Okay, I just remembered that for some reason. All right. Okay, I think we are good, and we don't have to worry about this too much. And so now I'm coming to an end. I have 2 more functional groups to go. I know there's a lot, but you know, when we were actually on person, I used to, you know, do this in 2 chapters. But I think, you know, there's no need, and we are going to be actually having another week off when I check my calendar. So we have 2 or 3 more to go. You can just review it, and you know, I know if you're taking the first time organic chemistry, it might be a little hard, but we just 3 more functional groups to go, guys. Okay. All right. So this is carboxylic acid, and now, as you can see, I can play around, right? And there's no end to playing around. So as we've seen in the alcohols, right? If you look at this OH, this is actually like that, right? So there's a hydrogen bonded to oxygen. Okay. And so what if I have carbonyl group again attached to an R group, but this time I'm attaching this hydrogen to another R group, right? Not a hydrogen, but another R group, right? So now if you do that, then you're going to have another functional groups, and this will be my esters. Okay, and again, these esters are we use in the fragrance and the flavor a lot, right? If you look at all those like flavor that we've seen, it's most likely that it's going to be the esters, right? Actually, in my organic chemistry class this week, we're going to make like pineapple and some banana, you know, flavors. And so people are going to like, the students are going to synthesize. You can synthesize these molecules, right, by mixing 2, you know, 2 functional groups. So again, these are going to be esters. And when you look at the esters, what do you see here? Right? Esters are a little bit interesting. So I think it deserves to be dive into a little further. So if you look at the esters, you see that, right? There's like 2 kind of like different group here. Okay. Can you right? If you actually look at it, if I divide here, right, like that, I have actually again maybe I can give you an example, or maybe that's okay, right? You can actually get esters. You can synthesize esters by mixing the carboxylic acids. This is my carboxylic acid that I've shown you with alcohol, right? So let's say, actually, I made a mistake with coloring. Let's use different coloring so that you can actually keep track. So OR, right? You see that, right? You see I have blue color and red color, right? So the blue color is actually coming from the carboxylic acid. So whenever you see the carbonyl is coming from the carboxylic acids. Okay, and whenever you mix the carboxylic acid with alcohol, right? Alcohol was ROH. You see that, right? Let's say O, R, and H, so that you can actually. And I need something different. Let's say black. You see that, right? So this is again carboxylic acid. If you mix these 2 up under acidic condition, okay. Again, I'm not going to go to mechanism, but as you can see, I'm seeing myself here. Okay, you can actually again you are losing this OHs and these hydrogens here, right? And you are losing water, and then you can synthesize your esters. Make sense? Okay. So again, we're not going to go into mechanism, but esters are, you can actually, again, synthesize by carboxylic acids
And
plus alcohols. Make sense? And this is how we synthesize, right? So if you want to make a pineapple, for instance, flavor, you actually synthesize the corresponding carboxylic acid, right? You mix the, you find the corresponding carboxylic acid and mix it up with the corresponding alcohol, and then they react together, and then you synthesize your esters. Okay, that's how we synthesize esters. All right. And again, this is what it is. Again, I'm showing you, for instance, if you have propanoic acid, right? If you have propanoic acid, you are, again, by mixing these two, you are losing water here, okay? And making a bond between this alcohol to propanoic acid, and then you are making your esters. Again, you don't have to worry about this so much, okay? But I'm just showing you where this ester is coming from. And again, esters has two parts, and the carbonyl part, right? The carbonyl part is coming from acid, okay? And the oxygen attached to our R group is coming from the alcohol part. Again, whenever you see an ester, you know that the carbonyl is coming from the acid part, and the other part is coming from the alcohol, basically. That's how you're gonna separate them.
so esters are they're not naturally, are they? It's not, esters are not a natural compound, right? It's a mixture of two different.
No, it's natural.
Okay.
It's
Because
natural. I mean,
we're
but
actually influenced the mixture here using a carbonic acid and alcohol.
say it again.
So we scientists, chemistry, we're actually synthesizing using the carbonic acid and the alcohol to make esters. So can you give me a natural ester?
Yeah, I mean, again, these are all natural. If you eat pineapple, pineapple is
an ester. All
yeah,
right.
it's an ester.
And
Pineapple is an ester. I forgot the name, but
Okay.
let me actually look it up real quick. Pineapple.
And that's what gives it the taste of the pineapple is the
Exactly.
ester.
It is an ester, but you know, in nature, you know, it can make the say it again. It can make it by itself, right?
Yes.
By using the enzymes or whatever.
Yeah,
But
yeah.
we can actually do this in the lab as well. And this is actually pineapple. And if you look at it, it's actually one, right? So you have alcohol here, C2, CH3, right? Ethyl.
Right.
And then on the other side, you have 1, 2, 3. So this is actually pineapple.
So
1, 2, 3.
So that's why they make pineapple vodka now, because they're mixing the flavoring. They're generating. Okay,
yeah. So again, you can actually make this pineapple in the lab, right? By mixing the carboxylic acid, which is this guy, corresponding carboxylic acid, with ethanol. You just put them together, and then you just heat it up, and then you're gonna get pineapple flavor. You're gonna, you know, if you don't believe it, you can try it at home.
No, I'd rather not, sir.
Right.
I'd rather not. I'll blow my shit up.
All right. Right, it's good. So again, this is one part is coming from the acid, the other part is coming from the alcohol, because this is important, because this is how we are going to name the esters. Okay, we are going to look at two parts, and we are going to identify the alcohol and acid part, and then we are going to name accordingly. So how we are going to name it, right? So if you look at this methyl propanate, this is actually, again, this is another flavor. It's kind of like a fruity smell, right? It's like a rum fruity smell or flavor. So now I know that, right? If you have a carboxylic group, right? This is my carboxylic acid part, right? Whenever you have, again, carbonyl, you're going to tell that this is my acid part, this is my acid part, and this is my alcohol part. Alcohol, right? And so now, if you have the acid part, right? If you have the alcohol part, you're just gonna name the R group here, right? What R group do you have here? You have only methyl, right? So therefore, you're just gonna name that first, which is methyl, okay? And then you're gonna come to the acid part. And how would you name this if it will be an acid? It will be, you're gonna be counting all the carbon here again, 1, 2, and 3. And so this will be propanoic acid, right? It will be propane, but now it's an acid. It's gonna be propanoic acid. But now, again, this is not an acid anymore because now we have an ester. So what you're gonna do is you're gonna drop the oic acid part, right? And now for the esters, that's what we are using actually, right? We're gonna use O8, okay? So it's gonna be propon. Actually, we're just gonna drop the IC, propanoic acid, sorry, right? This just IC, and we're gonna add O8. So it's gonna be propanoate, okay? It's a little complicated, it seems, but it's not. Once we do a couple questions, you're gonna see, okay? So it's gonna be, again, you're gonna add the methyl in front. So it's gonna be methyl propanoate. Make sense? Anyone?
Yeah.
Okay.
Yeah.
So let's do an example. I think it's gonna make more, right? So how would you name this? Again, I'm 100% sure that this is another flavor. Let's check it out.
2, 3.
Methyl.
So divide that. So that's 3.
So they use actually this is a sweet smell, and believe it or not, they use in the glues and nail polishes to make it like nice smell, you know. So it's not like a all right. So again, if you look at it, where is the carbonyl? Carbonyl is right here. So I can divide this up, right? So this is my acid part, and this is my alcohol part, right? If you have an acid, the rest is alcohol. And so if you have an alcohol, right, when it comes to alcohol, you're just gonna name the alkyl group, right? So what alkyl group is this? You have 2 carbon. What's the name?
Ethyl.
Ethyl. Very good. Ethyl. And so when it comes to acid now, I have how many carbon? Again, I'm gonna still count this one. 1, 2, and 3, right? So if you have 3, it will be again propane, right? But now it's propanoic acid. But now I want to give you the final answer. Now this is not an acid, this is an ester. So I'm going to erase the acid, and I'm going to erase the I and C, and I'm going to add ATE, right? Propanoate. And I'm going to bring this ethyl as well. So in front, I'm going to name, like, whenever I'm naming the esters, right? I'm kind of like naming the alcohol part first, and then giving the last name, which is propanoate. Okay.
So you're doing that because you're naming the alcohol. The rule that you have to do it by alphabet doesn't apply here.
Not so much, because you don't have to worry about it. Again, I'm not really giving you a complex things, but the rule says you're gonna name. You're gonna be actually putting the alcohol first. Okay, alcohol part first. That's the rule. because this is my last name, propanoate, right? Last name is more important, and otherwise you wouldn't telling me if it's an esters or what. Okay.
Now, when you okay, so the alcohol is always going to fall to the right of that double bonded carbon.
Not necessarily, but you gotta again. That's a good question, but let me see. Again, you gotta tell me, right?
Yeah.
Let's do another example here, because again, it depends, right? So if I draw the molecule, so how would you name this?
So you can see, I would subdivide it first. Put the alcohols on one side and the carbons on one side. But I have to count the carbons. 2 carbons.
Methyl propanoate.
Yeah.
Right, again, so back to Carlos' question, right? It's not going to be always right or left, right? It's how the molecule is given. So, but we knew, right? We know that if I divide this up, carbonyl is going to be my acid part, right? Carbonyl is going to be always acid, so the other half is going to be alcohol. And so I know that this is actually methyl. And if I look at this one, 1, 2, 3, so this will be propane, it will be propane, but now it's going to be propanoic acid. But now it's not propanoic acid, right? It's propanoate. So I'm going to add ATE, propanoate, right? So it's going to be methyl propanoate. Again, back to your question, right? You got to tell me, right? Again, if I give you, if I flip the molecule, you're not going to say it's going to be always right side or left side. You're just going to look at your carbonyl, Carlos, okay?
All
If
right.
the carbonyl is, you identify the carbonyl, that's going to be your acid.
Okay. So,
All right?
yeah.
So this is esters, and we are coming to end and almost there. We have 2 more functional groups and we are done, okay? I know it's been a long, it's not a long day, it's 9:30, but it's like a lot to digest here, I guess, but let's try to finish it up. Okay, so now we are gonna be actually introducing another functional groups, and this time, so far, right, if you look at all these compounds, you only see carbon and oxygen. So now what I want to introduce here is now from this chapter on, I'm going to bring the nitrogen, okay? And so if you have, again, carbon and nitrogen with a single bond, right, then we're going to call you an amines, okay? And if I want to give you the example, for instance, the ammonia, right, this is NH3, and this is actually ammonia. This is actually where we use in the bleach, right? If you have ammonia gas, if you mix it up with water, that's where you have ammonium hydroxide. That's actually, again, a cleaning reagent that we use, right? So it's ammonia. So if you look at the ammonia, it's actually attached to 3 hydrogen, right? Again, if you have 3 hydrogen attached to it, okay? So this is the, again, and then we have 2 lone pairs here like that. So this is the, again, simplest amines that you can have. But as you can imagine, you know, you can technically, right? You can actually change the H, right? Instead of hydrogen here, now I want to have another R group, right? You can actually put R group here. You see that, right? So this will be, again, amine too, right? And you can actually do another one. You can change, you can keep changing it. So you can have H, and then you can put another R and another R. Make sense? Or you can put another one. all R. Again, R is alkyl chain, right? So these are going to be, again, all amines, basically. Make sense? Okay.
And that has 3 groups in itself.
Yeah.
Okay.
And and so just like the alcohols, it's the same phenomenon, right? So you can actually have, right? If remember, like I told you about the alcohols, we have primary, secondary, and tertiary, right? It's again same thing, right? If you look at this nitrogen, it's attached to only one R group, right? If you look at this nitrogen, it's attached to one R group, one branch, then it's going to be primary amines. If the nitrogen is attached to two R groups, sorry, then it's secondary. And if nitrogen is branched to 3 R groups, then it's tertiary amines. Okay. All right. And again, starting from ammonia to primary amines. And the naming is very simple, okay? And how we're gonna name it? We're gonna name the alkyl group, right? And then we're just gonna put amines. So if I give you an example, like CH3 NH2, for instance, right? So if you have, what's the alkyl group here? This one. So the name of the alkyl group is methyl.
Right.
And I'm just going to add my functional groups, amine. Okay, simple, right? Not so complicated. And if you have more than one, right? If you look at this one, for instance, now you have 2 R group attached to the nitrogen. So it's the same thing, right? If you look at it now, you have methyl, and this is methyl. And if you have 2 methyl, we use di, right? So therefore, we're going to call dimethylamine. Okay. If the groups are different, same thing, right? So what's the name of this group? This is methyl. And this is ethyl. And how would you name it? Right? I'm going to call this again alphabetically. Ethyl comes before methyl. So it's going to be ethyl, methyl, amine. Okay? Okay, right? Carlos?
I'm breathing, man. I'm okay. I'm all right. I'm all right.
Because you're gonna have a week to digest it, so don't worry about it, okay?
Yeah. Yeah.
And
Weak.
you can always come back to watch the lecture too.
Yeah.
All right. Any question with the amines, everyone? Right. So let's do one example here. How would you name this? For instance. And let's do one more here. Okay, what's the first one?
I came up with methyl diethyl.
Okay, so this is again
Mean.
methyl, right?
Yeah. Yeah.
Very good.
Mean.
And now you have diethyl. Very good. So you have 2 of them. Okay, and so now if you look at this one, right, you're gonna actually name, not sure if I told you this, but yeah, we don't really count the di and tri and those suffix actually, right? And so therefore diethyl is gonna come before the methyl,
Dimethylamine.
and then what's the functional group?
Amine.
Amine. Okay, and these amines are actually is also if you look at these amines, they're actually very smelly, actually, you know, like a fish smell. So these chemicals are like really smelly, and whenever you are treating this, you want to like you treat it under the hood, because whenever you open the bottle of, like, say, the like triethylamine, it really stinks, you know. You don't want to like you know, smell it, so you want to like open it under the hood so that you don't like smell it. Okay. And so what about this one? This is the last example for amines, and I think we can move on. What's the alkyl group here?
Ethyl.
Ethyl, very good, right? We have 1 and 2. And now, if you look at it, all of them are same, right? 1 and 2, 1 and 2. So how many ethyl group do you have?
3.
Tri, right? So it's going to be again triethyl amine. Okay? Sounds fair, right? All right, so now this is the last functional group, guys. Yep, that's the last part. And now I want to show you again, we can actually have, we're going to bring back our friend, right? I'm going to have still my carbon attached to a nitrogen, but now what I want to do here is I want to bring actually my carbonyl, right? So in the last functional groups, I'm going to have still carbon attached to a nitrogen, but this time the carbon is going to be not regular carbon, it's going to be carbonyl. Okay, so as you can see, this is not the same with this guy, so we're going to call this actually amide. Amides. And as you can see, if you have an amides, right, again, you can put R here, doesn't really matter, and NH2, right? You can actually have, as you can see, and again, you can have different R group here too, right? You can have like hydrogen here or another R group, doesn't really matter, right? As long as you have nitrogen attached to a carbonyl, then it's gonna be an amide basically. So how can you get the amide? Just like the carboxylic acid, right? You can actually, as you can see, if you have, divide this up, right? Remember the esters, right? Whenever we have the esters, we said that we can actually have esters by combining carboxylic acid and alcohols. Same thing, right? You see, there's a carboxylic acid part here. So if I want to draw this molecule again, maybe accordingly. So now I have actually NH2, right? So if you mix it up, carboxylic acids plus amines, right? So this amines, again, we are not going to see the reactions and mechanism, but it can actually attack here. And again, you're going to lose water again, same thing, right? You're going to lose this OH, and you can actually, again, introduce your amides, okay? This is actually how, again, our body makes amides, NH3. So basically, right, if you look at the amide, it has, just like the esters, it has the carboxylic acid part, and it has also amine parts. Okay, if you mix them up together, then you get your amides. Make sense? And oops, where were we? Yeah. And again, these are going to be the formulas, I mean, general structures. And again, I kind of like mentioned to you, right? It doesn't really matter if you have 2 hydrogen or 1 hydrogen or no hydrogen. It's still okay, right? These are all going to be amide because you have carbonyl attached to a nitrogen, carbonyl attached to a nitrogen, carbonyl attached to a nitrogen, okay? These are all amides. And again, these are coming from whenever you mix up, just like the esters, whenever you mix up the carboxylic acids with the amine, if you lose water, then you can actually again get your amides. Okay, you are making a new bond, as you can see, between this nitrogen and this carbonyl, right? And you're actually synthesizing your amide. Again, we don't really care about this too much, but this amide is actually very important because it is the actually, when we see the proteins, right? All the proteins, right? And if you look at our body is full of proteins, right? It's actually it's based on the amino acids, okay? And if you link the amino acids together, then you are actually you're synthesizing proteins. And it's essentially all amide linkages, right? So if you look at the proteins, it's all about this linkage between carbon and nitrogen. And again, we are going to call this peptide linkages or amide linkages. It's the same thing basically, okay? If you have a peptide, it means that if you have a peptide bond, it is nothing but an amide functional group basically, okay? So again, once we I think that's the last chapter, not last chapter, I think that's right before the last chapter. Oh, I think it's the last chapter, yeah, proteins. So we're gonna see how this is gonna play out actually in that chapter. So we're not gonna go that into details. And so when it comes to naming, again, it is very, very simple again. So how we're gonna name it? Again, we're gonna count the number of atoms, okay? And we are gonna treat this now as if the carboxylic acid, right? So I know that this part is gonna be carboxylic acid, and I'm gonna count the carbon atoms, 1 and 2. So if you have 2 carbons, right? What will be the name? It will be ethane, right? And it will be ethanoic acid. So you're gonna drop the oic again, and you're gonna put amides basically, right? So it's gonna be ethane, right? Ethane, amide. Make sense? Ethane, amide. Not sure if I have an example here, but yes, we do. So how would you name this? Oh boy. You guys are tired, huh?
No. I'm. Oh, you
Sorry.
just changed the screen.
Sorry.
All right, so let's do.
I'm gonna
that.
stop sharing it. I'm just gonna share my PowerPoint because I wanna look for something else. Okay. So now if I switch the screen, what do you see now? Do you see my PowerPoint still?
Yes, I
Yeah.
see you.
Yes.
Okay, that's good.
This just has four carbons, so it's
Yeah.
butynomide, right?
Yep, right. So you're just gonna count the carbon of number of carbons. And let's just Why this is giving me a hard time? Today is 27, right? Yep. So I'm gonna give you
Yeah, there's no class, I think, next Saturday.
Oh, there's no class, right?
Yeah, for Easter.
Oh yeah.
Oh God, really?
So do you want to have another week then for this, or are you guys fine if I give you 1 week to finish this up? The quizzes. Or doesn't it matter?
Doesn't matter.
Yeah, I agree with you.
Yeah,
Doesn't
next
Whatever
yeah,
keeps us on track.
Yeah.
Yeah.
Okay, so let's keep the same pace then, I guess, because you want to have like this done this on fresh, right?
So this quiz will be due in 1 week, like normal.
Yeah, I mean, again, if you want, I can give you 2 weeks, but it's up to
No,
you
what
guys.
I think it's okay.
I think
Okay.
it's okay. Get it
Yeah, I
over
think
with.
so. Everybody's we wanna keep the same pace. Okay, so it's gonna be April 2nd, Friday midnight. Okay.
Yep.
So I'm just publishing this, but I wanna see the quizzes, but I can't see somehow. And I got a couple email actually. Thanks from a couple people. I made like some small mistakes, and but you know it wasn't so big. So so thank you for that, and I corrected that, and I kind of like regraded. Okay. And okay, so what's the name again?
So I got butamen. Butamen.
Okay, let's do it.
Butamen.
Yeah, so it's gonna be
Amen.
1, 2, 3, 4, right? So it's gonna be butane.
Yep.
And I'm gonna be making this butanoic acid,
yeah.
and I'm gonna drop the OIC and make it an amide, right? So it's gonna be butanamide,
Yeah.
right?
Mhm.
Okay, very good. All right, so that will be end to this chapter, and let's do a quick analysis of what we learned. Again, I'm not going to ask you. Let's do this quickly, okay? It's not going to be so bad. So now we've seen all of the functional groups, okay? And so if I want to ask you, like, to identify what functional group is this? Let's say this is first one, and this is second one. This is third, fourth, 5, 6. If I want to ask you which one is aldehyde, which one will be aldehyde?
Which one is the aldehyde? Even more.
Hmm.
Which one is aldehyde, everyone? You forgot everything we learned?
The first
I
one?
think
Yeah, number 1, right?
Yeah. So again, for aldehyde, right, what was our functional group? I need to look for R attached to an aldehyde, I mean, attached to a carbonyl, but I need to have a hydrogen, right?
yes.
So the hydrogen must be there next to the carbonyl. So as you can see, number 1 is my aldehyde, right? This is my carbonyl attached to hydrogen. Okay, everyone? Everybody see that, right?
Mhm.
Okay. So number one is my aldehyde. So how would you name the number one?
One, two, three. It'll be propane
Okay.
and propanol.
Propane, drop the E.
Add Al.
Very good. All right. So we checked out propanol. So what about the amide? Which one will be amide?
Those are carbon.
Amides.
Amide. So this is my aldehyde.
So I need a nitrogen and an oxygen.
Which one is my amide? Amide was what? R attached to a carbonyl
Yes.
to
So
nitrogen,
two?
right?
It's got to be number two.
2. Very good. So this is my amide again. So how would you name this? We just named it, I guess. But so you're gonna count again. You're gonna count the number of carbons, right? You're gonna count 1 here and 2 here. This is the carboxylic acid. So it's gonna be ethane.
Ethanol, and then change that
Right.
to
So it's gonna be
ethanic.
ethanoic acid, and I'm gonna drop the OH too. So it's
Yeah.
gonna be ethane, and I'm gonna add my functional group, which is ethane amide. Make sense?
Mm-hmm.
All right, very good. So which one is alcohol?
Number 3.
Number 3, right? Because now we have a OH again attached to R, because that's actually what is my alcohol, right?
Right, and it's
Yep. And how would you name this?
Butanol.
Okay, butanol, or you carefully count the carbon.
Oh,
I think you count one or less, more or
1, 2,
less.
3.
oh, 3. Okay, yeah. So
Propanol.
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 Yeah.
Propanol. Everybody agree?
Mm-hmm.
Okay. All right. Good. So let's move on. And what about ketone? Which one is ketone? Oh, by the way, what's the name of this? You said propanol.
Yeah, the number 3 is propanol.
Okay, very good. Are we missing anything though here?
Are we missing a number?
Exactly, right? Because is it 1 propanol or 2 propanol?
It should be 1 propanol.
Exactly, right? Because this is 1 propanol. If you have 2 propanol, the OH will be here, right?
Yes.
And if 2 propanol is actually isopropanol, and isopropanol is, you can buy it, you know, at the grocery stores that they use for cleaning purposes, you know. Okay, what about ketone? Which one is ketone here?
Ketone RCR with a double bond. So number 4 should be a ketone.
Yep, this is ketone. And how many carbons? Again, 1, 2, 3, 4, 5, 6. I think we did this. So this will be again hexanone, right? 2 hexanone.
Hexanol or hexatone.
Hexanone.
Hexanone. Yes.
O-E-N.
O-E-N.
Okay, which one is going to be ether here?
We're doing esters, you said? So
Ether,
it's going to
ether,
eat. Oh,
5.
ether.
5.
5, right? And how would you name the 5?
oh. Okay. Ethers.
Then
So it's O, 2 R's.
So this is methyl.
Uh-huh.
dimethyl.
What about this one? What's the name of this alkyl chain? How many carbon here?
Four.
Should be five.
One, right? Let's count. Let's count. 1, 2, 3, 4. So if you have 4,
But don't you have to count the double bond? Oh no, never mind. I'll shut up.
okay, it's okay. It's okay. So if you have 4, what will be the name of 4 carbon?
It should be butyl.
Butane, right?
Yes.
But now this is not a butane because this is an alkyl chain. So what will be the name of the alkyl chain then?
Dimethyl, no.
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 Butyl.
Butyl, right? Yeah, you're just
Yeah.
gonna change the butane to butyl,
Butyl.
All right.
right? Just like how we change the methane to methyl, right? Or ethane to ethyl, same
Mhm.
thing. Butane to butyl. Make sense? So therefore the name will be, right?
Butyl methate.
Butyl
Methate.
methyl. No. Methyl.
Oh.
What
Oh.
functional group is this?
It's
Ether, right? So it's gonna be
ether.
butyl methyl
ether.
ether.
That's
Make
not,
sense?
yes. So okay, and that's what I try to do. I try to use that as a suffix instead of using just calling
No,
it ether.
again, you have to count the number of carbon atoms. Tim was saying like dimethyl, but no, again, you think that if I give you this, right? But this whole thing is part of the alkyl chain. You cannot just count this as a metal. Okay,
Gotcha.
Right.
Mm-hmm.
you have to count the whole thing. All right. All right. And so this one, the last one is what functional group is this one?
Amide.
Not amide, but amide was this one, right? Stephanie? It was
Amine. I'm sorry.
amine, right? It's amine. Okay, very good. So it's amine. So how would you name this? We have a younger audience, I guess, Stephanie.
He's talking to me because every time you say something, I scream like that.
And he's learning too. He's learning organic chemistry. That's good. Okay, so this will be, again, you're just going to name the alkyl chains, right? So this is methyl. And what is this one?
That's,
How many carbon here?
2.
2, right? So it's 1
Ethyl.
and 2. So it's going to be ethyl, methyl, amine, right?
Uh-huh.
Okay. All right.
Yeah.
So that's good. So again, with these questions, we kind of like sum it up. And I just want to show you one more example before we go. And so if you look at this molecule, again, this looks like a very scary molecule, but it's actually not, right? And we don't really care about all this molecule, but this is, as you can see, this is like, I believe, I forgot the exact name, but it is used for the HIV, inhibitor, right? So to kind of like,
Stabilize.
huh?
Inhibitor means you're putting something to stabilize something.
Yeah, I mean, it's not like inhibitor, like it's actually one of the drug that they make it. So it inhibits the HIV and HIV viruses to kind of like do what it's supposed to do, right? So that it kind of like doesn't do, and so that the HIV patient can survive, basically, right? And so as you can see, this is like a very complex drug, but it doesn't really matter. But now you've seen some of the functional groups, right? So if I ask you here, right, what would you see? Like, do you see any alcohol here? Functional
Yes.
groups.
Yes.
Okay, where is it? I know you don't have a pen, but it is.
But it's in the middle and to the right a little bit. The OH.
Right? So
the OH.
here, right? Very
Yeah.
good. So as you can see, this is my alcohol, right? alcohol, okay? And what about I think we did in the aromatic, right? Yeah.
Yeah, we did the error. Yeah.
Yeah. So if you see any benzene ring like that, right, this will be my aromatic ring, right? So these are, again,
One,
these are
two,
all aromatic. So we have 2 aromatic ring here. Okay.
three.
All right. Yeah, it doesn't matter how many, but we
Okay.
have a functional groups, basically aromatic functional groups. Okay. So do you see any ketone here? This is kind of like a puzzles, right? You know those puzzles, like find the
Yeah, I don't see no ketones.
do you see any ketones?
Nope.
Everybody agree?
Nobody's gonna agree with me. OH.
Do you see any ketones and any aldehydes? Well, again, ketones were carbonyl group attached to R group, right?
Yes, there are an
Okay, what
aldehyde
about
group. That's an
yeah, what about
aldehyde group.
okay, what is aldehyde? No, I mean let's look at the ketone. So I have this carbonyl. So is this a ketone or what?
Yeah.
Yeah.
Yes or no?
Yes.
Everybody agree?
Yes, that's a ketone. Yep.
If that's a ketone, what is this then?
That's a amine.
Right? So this is an amide.
Amide. Yeah, with NH3. Okay.
Okay. So what is this then? Is this a ketone or amide?
Amide.
Amide, right? Again, you make sure, like, even though you have a carbonyl, it doesn't mean that you're going to have a ketone, because in the carbonyl, both of them has to be R. But here, if you look at it, right, this one is R, this one is carbon, but the other one is nitrogen.
Yeah.
You see that, right? And
So
same thing here, right? This is actually attached to another nitrogen. Same thing here, it's attached to nitrogen. Same thing here, it's attached to a nitrogen. You see that, right?
yeah.
So this is all amide. So there, I don't have any I don't have any ketone in this molecule, right? There's no ketone functional groups.
No.
Carlos,
Because-
you're right.
Huh?
Carlos was right.
Yeah.
Don't tell too many people.
Okay. So and what about amine? Do you see any amines here?
Amine. Yeah, I don't see no amines
Yes.
either.
Look closer.
Is that an amine with the nitrogen and the cyclic?
Right. So if you have, again, if you have nitrogen attached to a carbons, or it doesn't have to be a carbon,
There
right?
you go.
So as you can see, again, this is not amine though, right? This is not an amine, right? Because this is, we already said that this is an amide. But if you look at this one right here,
The one
this
above it.
actually, yep, actually this is actually one, see, is
Yeah.
attached to a carbons here, right?
Yeah.
So this is an amine, right? And also this one, this is a different type of amine, but it's still amine because nitrogen is again attached to carbon and carbon. So this is still, I can treat this as an amine as well. So we still have also amine as well. Okay. So as you can see, I may ask this type of question in the quizzes. Okay. I can give you the structure, and then I can ask you, what do we have or what we don't have? So you have to be looking carefully. Okay. All right. Anything else? Let me see. Yeah, I think we are fine. I think you did good. We did good. We covered pretty much very nicely. And so I think I'm going to stop here, guys.
Yeah,
unless you have any questions.
I do have a question,
Sure.
but this question is not based on boop, this chapter. It was based on the last chapter because I just saw it.
Okay.
All right, so